Okay, so last day I asked you or showed you how to come up with the equation for a graph. So you're given a graph. The path that we took is we went from the graph, we made a table, we picked consecutive values, found the pattern in the table just like we did in the quiz, to come up with the equation. So today we're going to use a different approach. This approach is used next year for you, but I think it's easier. We're going to jump the middle step, go straight from the graph to the equation. Okay? To do that, we need to have a better sense of what does the coefficient and the constant do. All right? So we have, let's go to here. So we're on this page. We said, at least I told you, that an equation for a line looks like this. Right?
What page is that?
We're page 10. It says page 10. All right? It's on day 3. Right? Or day 4. Day 4. Sorry, day 4.
I'm on day 4.
Yeah. Keep on going. Day 4, third page of day 4.
Oh, there's 3 pages?
Yeah.
I know.
Okay, so now, what we've been calling the coefficient and the constant, those are generic terms for how to express polynomials. Now, in terms of a line, we have more specific names for these two things. Okay? These two numbers have properties of the line. So you need to know what these properties of the line are, and that way you can create the equation so much faster. So I'm going to show you a graph of a line. Okay, so this is a graph of a line. I'm going to change the constant value. Right now it's at 1. I'm going to keep the coefficient the same. I increase the constant value up to 2. That's how the graph looks. I change the coefficient, so the constant up to 3. That's how the line looks. What's staying the same? What's changing? What do you notice happening?
It's going higher, but the angle's the same.
Right? The angle's the same, and Mason's like, yeah, it's going up higher, right? So what's happening is this value here is your, what we call your y-intercept, where your line crosses the y-axis. So at the very first line in red here, it crosses at 1. Second line in blue crosses at 2, matches up. Third line crosses at 3. Okay? So you can read your constant value right off the graph. Okay, so we're going to go back to our notes here. We're going to add that in. So this is called our y-intercept. Right? Or maybe I'll use a different color. Where the line crosses the y-axis. Okay, so that number, you can just read off the graph now. Okay. Okay. So the m value, which we've been calling the coefficient, that has a different property of the line. So the intercept makes it go up and down. So I can go back to my graphing tool right here, and I turn these guys off. Okay, so right now my coefficient is 0.5. I'm going to keep my y-intercept the same, and I'm just going to make the coefficient bigger. I'm going to go from 0.5 to 1 to 2. You tell me what you notice for the property. So here it's jumping up to coefficient up to 1. Now it's jumping the coefficient up to 2. What do you notice? What stays the same? What changes? Noah? The angle changes. So the y-intercept doesn't change because that all stayed at 1. The angle changes. Now, in terms of a line, we refer to that angle as slope or steepness or rate, all meaning the exact same thing. So it just gets steeper or shallower, depending if the numbers get smaller. The bigger it gets, right? the more steep it gets. So this is called our slope, or in science class, you're going to use the word rate a lot for this because that's how quickly do things change. This is called slope or rate, or in English we talk about steepness. Right? So math, we usually say slope. Science class, we usually say rate. In everyday English, we say how steep it is, right? Okay, so let's go to over here. And we have our general formula for our equation of our line, mx plus b. Right? M stands for slope, b stands for y-intercept. The y-intercept is the really easy one to figure out. So this graph here, at what number does the line cross the y-axis? Prof? Negative 4? No, these are positive numbers. That's just the line going through. So 4. All right? So it crosses right here. This is the number 4. So we know our b value is 4. Okay? Now we need to figure out what the slope is. What's the steepness of this thing? That's a little bit harder to do. Not too bad. Right? So we use this formula, which we're going to say m is equal to your rise over run. Okay? So we need to use it. We need to pick 2 spots on the line. It doesn't matter which spots you pick, but you pick ones that are easy to read. So I'll pick this one here because it crosses at some nice numbers. Right? So I'm going to pick this spot here. And then go pick another spot where it's nice to read. Oh, it looks like it crosses nicely over there. So I'm going to put that, another dot there. So I make these 2 dots. And with these 2 dots, I'm going to create a triangle. So I can go this way, out. And this way, up. Okay, so we made a triangle. And off this triangle, we need to figure out what the rise and the run is. Okay, the rise is, hey, how far did we go up between these 2 points? Or how far did we go down? So the rise is this part. How much did we go up or down? So we started at 10 and we went all the way up to 20. So we moved 10. So our rise is 10. Okay? Our run is how far did we move horizontally. So you're looking at how far did you move vertically and how far did you move horizontally. Horizontally, we were here and we went all the way to there. Right? So we went from 3 all the way to 8. How far did we move? 5. Okay? And then you go 10 over 5 is my slope, which is a fraction which we can make a little bit, clean it up, right? What's 10 over 5? 2. Okay? So now, this is 2x plus 4. And you have the equation of the line. Right? So the y-intercept, you read off the graph. Your slope, you make a triangle between the 2 points and see how far did you move up vertically, how far did you move horizontally. So now, thinking of this rate is kind of nice too, right? Because it kind of connects back to our table. So if you go back to this day here, right? Right? We usually go, how far did you move? For every 1 moving here, we moved 1.5 there. This is doing the rise over run in a table format. We're doing the same thing. And then we had this weird question here is we go, oh, we had to jump up by, so we jumped by 6 here, but we jumped by 2 here. So we had to then divide by 2, right? This is for every 1. So that's how the rise and run works. So it's like, how far do you move over here? How far does this move? It's all relative, right? And next year, you'll get into talking about a graph and you'll be talking about it using equations as well. It may look a little bit more complicated, but it simplifies down to this. This is where it starts off, right? And I like this because I think it's a little bit easier to figure out. And the table method is a little bit harder when your slope, your coefficient, is a decimal number, right? How are you supposed to create a table here, then pick numbers, and then it ends up this number ends up being a decimal? That becomes harder to do. Whereas here, you're just picking 2 points and whatever's nice to read, and if it's a decimal number, it's a decimal number. You don't have to kind of figure out what that decimal number is.
What do you do if none of all the lines don't line up on a nice?
So then you do your approximate reading. All right, so you read off of maybe a 1.6 or 1.2 or something like that. For the purposes of grade 9, I don't think I will do anything where it doesn't line up nicely for you. All right, but you can just read whatever value. Okay, so let's try this again. Okay, so let's go to this one, where you have y is equal to mx plus b. All right, we're going to find our b value first, our y-intercept. So for this graph, where does our line intercept the y-axis? Where does our line cross the y-axis? At what number? 6. It crosses right here. That's at 6. So our b value is 6. All right, now we need to figure out our m value. Okay, so we need to pick 2 spots on the line, which is nice to read, right? Doesn't matter which ones we pick. All right, so I don't know where's a nice one. I see a good one right here. That one looks like pretty good. And another one, let's see, maybe at the 2. That's not too bad right here to read. Okay, so now we make our triangle between these 2 points. Now it doesn't matter which 2 points you pick. It always turn out to be the same number. Okay, so don't worry about is this the right point or that's the right point. It's always going to be the same number. So our slope is our rise over 1. How did we change vertically? How did we change horizontally? So let's do the vertical one first. Right? We started down here. What number did we start at here? 9. Right? And we went up to 15. How far did we move? 6. So our rise is 6. Okay? Then going horizontally, this one we start at 2. We ended up at the number 6. How far did we move horizontally? 4. So our slope is 6 over 4. Or we can simplify that fraction because they're both even numbers. Right? So we can divide by 2. So just 3 over 2. Okay? So our slope is 3 over 2x. So our equation is y equals 3 over 2x plus 6. Okay? So at the beginning of this chapter I said, hey, it's not really that difficult of a chapter, but there's lots of little things that you got to know. That makes it hard, right? So you got to be really careful with your notes. Make sure you're writing everything down, right? Because you're going to forget these things. You're going to make mistakes, right?
Can I go to the washroom?
One more question for you, Mason, then you can go. All right? Okay. Last one. Y equals mx plus b. All right? Now you need to be careful. Where does the line cross the y-axis? Not the x-axis, the y-axis. 10, right? It crosses right here. That's the number 10. Okay? All right. So now we need to make a triangle. Right? You pick some nice points. To me, I look at this, and you can pick different points to me and see if if you don't like my point, see if your answer comes up to the same. I'm going to pick this point, and I'm going to pick this point. Right? Why not? They're easy to read. They're right on the axes. Right? I go like this, and then go like this. I want to find my rise over run. All right? My rise is how far do we move vertically? All right? Between 10 and 0, how far do we move? 10. Between 0 and 5, how far do we move? 5. And 10 divided by 5 is 2. Now, so you have 2x plus 10. This isn't quite the right answer. Okay? There's something different about this line compared to the other two lines. You guys notice something different?
It's going down.
It's going down, right? You think of time moving to the right, these lines are going up. So our steepness is positive. Here, our line is going down. So our slope is actually negative 2. Negative 2x. Okay? So now if I go back to my graph here, and if I look, get rid of this, get rid of this. So exact same line, I haven't typed this one in. So I'll go y equals negative a half x plus 1. You'll see the exact same line with the exact same steepness, but pointing in the other direction. Right? So positive slopes point up this way, negative slopes point down. So when you're doing that, that's something you need to keep in mind. All right? So stop right there.